Right, so welcome to today's session, kind of a hybrid here. We'll start with the split plot and the other multi-factor designs in ARM. We'll create a protocol with those, and then we'll also actually generate a trial so we can see the trial map and give a little, some hints about the analysis as well. Then when we kind of wrap that up, we'll transition to applications, tips and tricks there. So without further ado, we'll go dive right into the ARM here for our multi-factor designs. So I'm just going to start by creating a new protocol. So of course, as you create a new protocol, we'll choose the general study definition. But the one trick, if you're working on a multi-factor design, when you get to this new protocol screen, instead of just pressing OK to get into the file and start working, we actually want to go to the protocol settings. And we'll see why in a moment. Yes.
Can I just interrupt? A question for the group might be, when you're selecting the definition file, why we use the G all one and why we don't use the other two that are listed, and where you might use those other two? Yes,
great question. Looks like I don't have a back button, so I'll just start again. That's a great question. No, and that's an excellent one. The first question is, of course, if you were working with one of the large corporate global sponsors that have their own customizations, but everyone would pick myself there. But yeah, as you pointed out, there's actually 3 options here on this screen. And almost all of the time, you want the G all. That's the multidiscipline. It really has most of the development time go into it and features for all different kinds of research. The one exception to that rule would be if you have a study that is strictly a variety study. If you don't have any chemistries that are being mixed up or anything like that, just seed varieties are all that's going on in the treatment list, then the G seed can be useful. Essentially, it's a subset of the G all with a few different terminology differences that really match a variety study. So that would be the one scenario you'd pick something else, as if your study is seeds and that's it, or variety. And that's all. The G-Gen, that has absolutely no chemical, nothing to it. There's really nothing to it. So it really would have a hard time finding a good, legitimate reason to use this. The only example I've heard is a university professor used it years ago for their one of their classes. So each student was a plot or a replicate, something like that. So not exactly research specific. So, and then of course, here's a nice spot to look at the language as well. So if you are working in a different language, all of the prompts on the screen that you see have a variety. We have a variety of different translations for those. So great question. And so once we get to that next step here, again, just the slight trick here is to open up your protocol settings first. And when we go to the settings, we're going to open up the design tab and have a look at the list of designs we have in ARM. So real briefly, just to highlight, by far and away the most common one in the industry is RCB, the randomized complete block. But we do have support for a variety of other blocking schemes like Latin square, a bunch of different types of lattice designs, completely random on the other side where there is no blocking at all. For the CRD, we have support for some augmented designs. But today's focus is really going to be these last 4. So the Factorial RCB, Factorial CRD, split plot, and strip block. Those are all types of multi-factor designs. I'm just going to pick the first one here just to show what I mean by multi-factor if you haven't worked on that before. And we really are going to specify particular components, if you imagine your treatment list of what you're going to test, you might have multiple different types of the thing you want to focus on. And so really what you'd like to know is want to test all the different combinations of these, two different things I'm looking at. So today's example, just to have something that we can talk through, even though it's totally fabricated, I don't have any real data or anything. I'm gonna say that we've got 3 different tillage types that we want to perform and see how 4 different herbicide products perform on each of those different tillage types. And so that phrase "on each," or kind of multiplying them out to see every combination, is really the key for a multi-factor design. And that's where you can gain some statistical abilities per se by doing every combination of those things that you want to look at. And so that's really the goal with the multi-factor. And so once you've chosen a multi-factor design, then here on the screen, the next section is to describe those, what we call factors. So the factor A in my case would be the tillage type. And so here from this list, I can certainly hand type, or you can pick from this list as well as just different types of common factors that might be used. So here I've got a tillage type available to me. So I'll just pick that. And then for the oops, I should change my number. So the tillage type is kind of the category of what we are looking at. And then I'll tell ARM I actually have 3 different ones that I want to look at. And so those are known as the factor levels that we'll have for the different tillage types. And then we'll go for our second layer. The second level is our product, our herbicide. So I'm going to go down here, and I've got an herbicide link as well. So now we can say that other factor for each tillage type, I want to have all four different products that will be used. So that's really the general construct of a multi-factor design. Returning back to this list, I had just chosen the first one, Factorial RCB. So when we randomize the trial, it'll be much like a typical RCB design where we'll have our replicate, in blocks. So each individual treatment, after they've been multiplied out, will live just once in each block that we have across the field or greenhouse, wherever we're holding this at. Prior to 2022, that was the only, we'll call it regular Factorial design. And we had just called it Factorial, but we do now offer a Factorial CRD design. And I've got just a PowerPoint slide on that to kind of visualize that this was added here just in the last update of ARM here, or I guess it was 2021.7. So one of the last 2 updates, it would have been added. And so essentially this is a completely random design with a factorial arrangement of treatments. So we just kind of defined that factorial way of having our treatments set up. And now here we're kind of specifying what should happen on the trial map. So the CRD, there is no blocking. Those treatments can end up anywhere and everywhere. I mean, as you can see on this map, there's no rule forcing, there's treatment 7 here. So it's on this block, but there's actually 2 of them in the 3rd block. There's no blocks at all, actually. It's just the map. So that was added to ARM. Really the goal to be useful in greenhouse studies mostly is where the request came in. So in a greenhouse, there is no known gradient that you need to block for. There's a lot of flexibility in where things are placed. And so the completely random design is much more common. So really wanting to bring that possibility that we have a CRD design in ARM, bring that to the multi-factor world per se in there. And so previously in ARM, we had just called the RCB factorial, we just called that the factorial design because it was the only one that was in that category. Now we renamed it to factorial RCB to kind of clarify the difference. So if you're used to seeing just factorial, that's now why there's two, because we have two different flavors to be able to choose from. So my example here, it will say is a field trial. So we definitely will, would choose the RCB probably. But moving on to the other two options, now the split plot design is a kind of a subset of an RCB design. And the goal with the split plot is when there's kind of a special rule that has to apply when we're randomizing. And so I chose this example with tillage type specifically to target a split plot design. In some cases, you're limited as to how you can randomize the trial. So something like tillage type, maybe out in the field, my equipment is much too large to be able to, till only a single plot and then have a complete checkerboard of different tillage types just willy-nilly throughout the field. It's just physically not possible to do that. I've got to drive my tractor down a stretch, and that's going to be all one tillage type. And then I can hook up to the other equipment and do something else on the way back, but they're all going to have to be grouped. So a scenario like that where you're forced to kind of group one of your factors is where a split plot design comes into play. And so I've chosen tillage type specifically as my factor A because that's the factor that I have less control of when it comes to randomizing. And so we'll see that in a little bit, be able to actually kind of visualize that on the trial map when we randomize. But that will be what we choose for this example, so we can kind of see how that affects the map. And that's really the key, is it's the same approach to the treatments, but it's just the impact on the trial map of where plots need to be. And then the last option is, taking the split plot one step further, called a strip block, or crisscross as it sometimes is known. And so that takes the split plot, and then within your kind of forced factor levels where you have to have them together, it actually would split them up into separate rows. It's a little hard to visualize. Usually what I do at that point when I'm trying to explain that is I'll go to the help button here, and I'll see if it even comes up. My monitor sometimes eats that window. And I've got a link here for the experimental design and establishment, where it'll kind of explain and give an example for each one. And down here at the bottom, there's our write-up of split plot. So there we use that tillage method, and they're all forced to kind of be next to each other. The strip block takes that one level farther and puts them kind of perpendicular with each other instead. So maybe there's another kind of issue with how things have to be arranged. And so that's the advantage of the crisscross. I think it's a little less common, at least I certainly don't get too many questions on that, but I know the split plot is definitely a pretty common one. Again, just kind of depending on the type of research you do, you kind of might be forced into a corner when it comes to the randomizing. And so ARM has support for those designs, not just to get the randomization the way you want, but then we'll also see how the analysis will be intelligent for that as well, and factor in that the way that things were randomized. All right. So that was the key here for multi-factor design, is to try to get into the protocol settings before you've totally made it into the protocol. Certainly not a requirement. If you come back and change it, that is okay. But we'll see in just 1 second why it is beneficial to set this up ahead of time. Because now if I say okay, and now we will press OK to actually generate our protocol. The key difference here, really the whole trial is going to be the same. We use that same study definition as we do for any trial, but with the design being a multi-factor now, you will see a difference on the treatment editor. So here now in our treatments editor, we actually have a couple of different sections in our editor. And so that's where I kind of like to show people to get into the protocol settings before you get to the protocol itself, so that way ARM can set this list up from scratch. And usually works a little better, although you certainly can shoehorn a study that's already been started on into a multi-factor design too if you had to. But this is kind of the easiest way to get going with it. So here, what we're doing is, instead of strictly just giving the typical treatment list that you would do in a regular design, we're actually going to describe the factor levels. So in our case here, we're going to describe the 3 different tillage types that are going to be involved. And then we'll go down here and describe the 4 different herbicide products that are involved. And then there is a section for comparison treatments. That would be any other treatment that's really not involved in this factorial arrangement, but for whatever reason, is part of the design, part of the study in the field. It's a little less common. I typically ask the groups if they have a really good example of where they've used comparison treatments before, and I usually don't get a whole lot of feedback. I don't think it's terribly common, but I do try to include a comparison treatment just so people can see what happens if they are in a case where they end up using it. So I will include one here, and you can see with the numbering, we'll just start over at 1 for each of these different sections, even though in the end, this comparison treatment will be number 13 probably, because we'll have 12 regular treatments and this will be at the very end. But I'm just going to call this comparison. Again, we don't have a terribly compelling example for it. You'll see at the very end when we're doing the analysis as well, that comparison treatment is not included in the factorial analysis that we have. So it's really kind of a outsider, if you will. Just in case you run into it at some point, we'll include it today just to see what happens.
Okay.
Yes.
We use a lot comparison in factorial design when we'd like later on compare the best treatment. For example, if I select factor A level 1 with factor B level 2 as the best treatment, and then later on, if you'd like to know how it's compared to the standard, for example, a comparison must application will be a standard compound, or in some case, untreated compound, just to make sure the trial was in a very nice infestation or infection, whatever. So that is very useful. We always use a standard extra treatment in this case. For sure, the analysis will be a separate analysis, but it's very helpful to have that standard in the same set of trial. It's very helpful. Okay.
Very good. Well, thanks for that. That's good to know. As a good reference then to see how your best choice stacks up against the standard. That makes a lot of sense. So good. So I changed my name a little bit here, so we'll see it later on as that standard then. That's a good example to have. So just real briefly, I won't really cover all the details of filling in the treatment editor. Really, the same rules apply as any other study. Sometimes something here like the tillage type, you wouldn't really categorize as a treatment necessarily. So of course, there's no formulation involved with tillage. There's really no rate. So what I recommend is simply using the treatment name as the location to just give that descriptor of what that level is. In our case, what is the type of tillage that's being performed. And I'm going to provide an exceptionally boring example and just call it tillage 1, tillage 2, and tillage 3. The fact that I am not a researcher usually surfaces in each webinar I do, and this one it came up pretty quickly. So instead of making up something that certainly won't be totally accurate, we'll just totally fabricate things. So that'll be our 3 tillage types that are being done. And maybe our first product actually isn't a product. Maybe we want it to be the check. That could certainly be allowed as well. So I'm going to change my type to check for the first one, and that will be an untreated. So I want to have each tillage type will have a plot there that is not treated at all. Give us a nice reference to see what kind of pressure we do get in the end. And so again, to reiterate that, we'll end up with each level of factor B on each one of these factor A's. And again, I'm not going to be terribly exciting. We'll call this product 1, product 2, product 3, our herbicides or whatever type of product we might be interested in seeing their performance against all of those tillage types. And now, of course, for these, we could get more interesting and fill in the formulation and the rate and all of that, but we won't bother in this case, and we'll just kind of leave our list like that. So typically at this point, I'm ready to kind of create a trial so we can actually kind of start to get a feel for what this will actually look like in a trial. However, we do have some recent development, another feature here within the last version or 2 of ARM that can be useful in these cases. And it's a tool to multiply out treatments. And so here under the Tools menu, you'll find that command, and it will convert the protocol factor levels that we just described into that full multiplied out list. And it'll actually do this while we're still in the protocol. So before this feature, we really were stuck with this view each and every time. And then only once we actually randomized and created the trial would we be able to see kind of our more classic view of a treatment list with all the unique treatments in it. But now we have the ability to multiply out our treatments here in the protocol. Now, the only caveat is when it does that, it is going to want you to save this study. And strictly speaking, we can't uncombine the list later on. So once we've done this, then there is really no going back to this format. And really the main reason, I'll go back to my slides here to kind of talk through the reason for it, is in some cases, you might need to edit that treatment list while still in the protocol. So I kind of find 2 uses for it. I've used it just to kind of preview as we're kind of working to see, is this, setting up that protocol right? Is this what I want to have in the trial? And I'll just multiply out the factors and see if that list looks good. And if it does, yep, that's what we're expecting, then you can use the edit undo, while you're still in that same workflow in ARM and do an edit, undo, and that will put things back the way it was. If you save the file after you've multiplied it out, close, come back later, then that undo is gone. So you want to kind of just be aware of that as you're working on it. But really the primary example where you might want to use this feature, here we have a made up protocol where we've got 3 different products as our main factor, and we want to apply each of them at a different rate. And so really it's a low rate, a medium rate, and a high rate, a kind of a multiplier to them. But each of these products have their own different rate that they're typically applied. So we really, when we multiply out that list, you don't end up with a straightforward list. So this ends up being a little bit of a mess. I apologize if it's a little small, but it ends up being kind of a mess. If you just handed that protocol to a trialist, you're really going to have to hope that they really understand what's actually going on, because this is kind of a mess, is what they would end up with when they create that trial. And so the purpose of this multiply out treatments development was to allow the protocol writer to get to this stage and clean things up. And so here now what the protocol writer can do is clean up that list and adjust the rate accordingly. So here, for example, our first herbicide product started out at a rate of 2 pounds active per acre. And then as the rate increases, that number changes. So 2, 3, and 4 become our first 3 treatments, whereas these other products have a different rate as well. So we kind of cleaned up, you kind of applied that multiplier essentially, and now we have a simple, clear treatment list that's still in the protocol that we can hand off to all of our trialists without a bunch of confusion. So that's really the main purpose of the multiply out treatment. So if you're in kind of a situation where, boy, this is going to make a mess when I get to the trial, now you kind of have the ability to get that list the way you want while it's still in the protocol. So that way all of your trialists can have that same clean list from the get-go. So in my case, I'm going to say no, we won't bother multiplying it out and just keep it as is here. So with that, let's create a trial. As I pointed out here, everything else in a multi-factor design is identical. We haven't changed what you would document. There's no difference in the assessment data to describe your headers. Everything else is the same. It really just comes down to the treatment description here in a protocol. So now when we create a trial, and I didn't give myself a trial ID, so ARM wants us to do that. I suppose I should probably save this just in case something goes poorly. I'll just drop this in here. Now we'll get to see the trial map and really see what the split plot will do for us when we randomize this map here. And so our trial map, right now we have colored by factor A. So you'll notice that for each plot, we have our plot number and our treatment assignment, but we also have an A and a B, which corresponds to those factors. So A again was our different tillage types. In this case, A2, so our second tillage type. And then the Bs were our herbicide products. And so that tells us which of the herbicide products, the B2 corresponds to product 1. So you can see that there's kind of a pattern to our coloring where we have our tillage types are grouped. So all of the A2s if we look across this whole replicate 1 here, you can see that all the A2s are clustered together, and then the A1s are clustered and the A3s are clustered. That's really the split plot design. And now we are free to choose where within the replicate the A1 is and the A2 and the A3 is, but then they're grouped within that. And that is known as the main unit. And then within that, all of the Bs are randomly assigned. We just so happen to have the same assignment here, 2, 3, 1, 4, happen both next to each other, but you can see 1, 2, 4, 3. It is different in each one of those other main unit sections there. So that's the split plot part of it. We can auto select for move to change where things are assigned, and we can actually move that main unit. So if I click on plot 101, when I want to auto select the main unit, you can see it's actually going to grab all 4 of these plots together, and I can move and switch those around. So I could manually, thinking of the tillage situation, as we'd said, where we're kind of stuck just driving the tractor down the field, maybe we want to have all of the A's in kind of the same spot on the map. So we could certainly kind of manually drag these around in order to achieve that. And that would kind of, accomplish that goal. And another trick for that, if you go into the layout settings, this is really our options that control how the trial map is generated. The very last option has to do with the split plot design. And we can tell ARM to not randomize those A's. So within every replicate, I want A1 chosen first, and then the set of A2s, and then the set of A3s. And that will automatically then give us that nice arrangement that we had kind of manually created a moment ago. So this is generating a totally new randomization since we changed our settings. Totally new randomization, except now you can see our pattern is in place because those A1s are first in each replicate. So, depending on your design, what you're kind of limited to, you can get that split plot to, you can get ARM to set up the map as it needs to be while still having randomization. You can see if we color by treatment, we still have a randomization. It's of course limited in that treatments 1 through 4 only occur, in this third of the field, et cetera, but there is still randomization here. So having the computer generate that can be good to not have any accidental bias. You will notice that we do have a 13th plot here, and that was that comparison treatment. And again, it's kind of just a third wheel to this whole process in that it's not going to be involved in any of this randomization. It's just going to be kind of on the tail end of the replicate. If you need to, you can always, insert, we could insert a column and have and move around a plot if we need to. So if you want those to be dispersed a little bit, you can certainly do that and do some manual changing of the map. But by default, that comparison treatment is just going to be kind of hanging out. Didn't get that to move over, but that's all right. So that's really the split plot. If we were just using the factorial RCB, we wouldn't really have this fancy pattern. We would still see the A1 and then the B4s. We'd still have that, denotation on here because that's the multi-factor. But really, there would be no pattern. They could totally exist wherever they want within their own replicate. or that factorial CRD, like we saw in the slide, could be anywhere in the map, totally dispersed. So it's just kind of a matter of automating that randomization to some extent of what you need to do. All right, so I'm going to accept current as is, and we'll say that that's good enough for our map here today. So now when we get into the trial, we can see that our treatment editor has returned to normal to some extent. And we now have a full list of treatments. And so you can see that we've had that multiplication of factors here. So our tillage, our first tillage type is being paired with the check, and then it's being paired with our first, second, and third products. All four of those product levels are paired with the treatment one, or the tillage one. Excuse me. And then the same thing starts over, that same pattern with our tillage two, with all four of the products, and then tillage three. So that's that full list. And again, nothing else is really particularly special about these trials. Everything, the site description is going to look the exact same. The assessment data is going to be the exact same as well. We'll have plot numbers, but they're no different than any other study. So one last thing to cover quickly here for the multi-factor. I'm going to open up a tutorial study. So we actually have some data in here. We're going to use I'll just click on this tutorial box at the bottom here. And let's filter by trials, the split plot here. If you haven't used this tutorial list before, we have quite a variety of different trials and protocols. We try to give it a name that kind of matches what it's trying to show off a little bit. So in this case, it's a split plot design here. So it's pretty similar to the example I had given. Just real quick for anyone curious about it, I'll just go to settings. That's probably the quickest way to see what we have is herbicide products again, 3 different products, and then the rate of treatment. So that was what we had used in the slides. So there's this description. You can see 3 different made up products that are being applied at 3 different rates. So here we just have some assessments. They're a control rating at different time periods throughout the season. So the key then in a trial that has the multi-factor design, when you're going to do the analysis, instead of running the AOV means table, which is done most commonly for your analysis, underneath that we have a factorial AOV table. So this is the one to use for a multi-factor design. I don't need my data collection here. It's going to be very similar to the AOV table. You'll probably recognize a lot of these options look very similar, but there'll be some important differences. I'm going to press next just so I can preview the report on the whole screen. I'll just take the defaults for the header lines. There we go. Let's preview on the screen here. So this report is for any multi-factor design. And we really just get to have a slightly different look. It's structured pretty similar to the AOV means table. We have each data column is going to be reported in the report. You have that header section at the top to describe your assessment. But now instead of just your list of treatments, we have a few different tables of analysis here. So the first one we get is a table of replicate means. So, and that's really all we're doing is reporting replicate means in each column. There's no statistics going on here. But the next table is basically a cross section of our study. In this case, we get to see the factor A levels. So we get to see the mean of our products combined across all the different rates. So this is a grand mean of sorts for the three different, the three different times we used a chord in this product in our treatment list, both the low, the medium, and the high rate. All three of those were combined together to give us an overall average of what that product had done. And the same thing for each other product. So this can tell us and give us an idea of the significance of those different levels, totally ignoring the other factor. And then of course we get to do the exact opposite, looking at the factor B, so the rate of treatment. So regardless of what product it is, how did the low rate do relative to the medium rate, relative to the high rate? In this case, it was pretty linear. It looks like that things got better or worse, depending on what the assessment was, as the rate increased. So that's kind of an advantage to the multi-factor. Now you can look at each of those cross sections and get a sense of what happened. And then finally, we have the A times B means. That's really all of the combinations. And that falls onto my next page here. And so with the means, we have the mean separation letters and the statistics as well. So in addition to that table, again, a lot like the AOV means table that we have, we also have the AOV table to kind of see how the analysis split up the variance. Oops, sorry, my scrolling is taken off on me. So we have you'll notice the heading here is a complete split plot, least square estimation AOV table. And for this particular data column, eventually it tells me in parentheses, that's column number 1. So that's the important thing here is ARM, since we put in the settings, this was a split plot design, ARM is tailoring the analysis to consider what we had to do to randomize the plots. So it's kind of an inherent advantage to getting the design right in ARM, because the reports will take that into account as well. Now, I'm not a statistician, so that's about as far as I can actually explain the differences, but I do know it is different. And you can see the breakup of how it has broken up the different sources of error and variance in the data column here. And one value that I think stands out, if the rest of this is kind of gibberish, the one value that is pretty interesting to look at would be the p-value for the AB row. This would be your interaction. So in our case here in this column, there is significant interaction between our two factors, at least for this particular assessment. So again, depending on the study, that may mean different things. In our case, it tells us that the rate of the product, and both the rate of the product, low, medium, high, and the product itself is going to matter as far as what performance we get. And maybe our objective is exactly that, or maybe that's going to maybe confound some of the the conclusions we were hoping to draw. again, it really is pretty specific to what you're looking at in your design. But drawing that value out and making note of that is important in a multi-factor design. And you can see, of course, this repeats for each assessment. So, one particular assessment, it might not be too important, but either your most important assessment, that yield column in the end, or whatever your main objective for that product might be, or over the course of all of the assessments. Here we do have a case where one of the columns we did not have interaction, which might be interesting. So at any rate, we'll let the conclusions be drawn based on your own example of what you're working on, but that value matters. And again, these tables are just repeating. We have one assessment table for each data column in the study. So that's why it just continues on there. Then we just have the D codes list at the bottom. So just to reiterate on the analysis portion, that's one step I think some people miss. The factorial AOV table is a separate report that you can run in a multi-factor design. It can be statistically valid to take a look at the regular AOV means table as well. Essentially, you would be basically deprecating your design from a multi-factor into an RCB instead, is essentially what would be happening here. And it's certainly possible to take a look at that. In our example before, where we had that comparison treatment, that might be valuable to do because the comparison treatment was nowhere to be found on that factorial AOV table. It is automatically completely dropped from the analysis. But here in the AOV means table, every treatment is equal per se, as far as that goes. And here you can see that untreated check is here. So it's included in the analysis, whereas the factorial, any comparison treatment is not, because it's not part of that design. So that can be useful to be able to compare to that comparison treatment that you brought along for the ride, and see how the different combinations might have stacked up with that, or pulled the LSD value so you can do the comparison as Pavan had suggested from the best, whichever one was the best one of that combination. Now you can do a comparison to that comparison treatment. Just real quickly, just to point out one last feature that has been added pretty recently. This is related to that reporting. It brings in the level descriptions instead of just the treatment information. And that will show up on the factorial AOV table, also the treatments report for any multi-factor design. So that level description is what we had pointed at when we were looking at the trial map. And it's also on the settings. And it's just kind of a nice, simple way to, I guess I should say, it's a way to have a nice, simple description when you refer to those different levels. Previously on the report, you would have any of the treatment fields included, just like on the AOV report. And so in some cases, that's just overkill. In our example trial that we have here, it kind of is. We just want to refer to the product, and we want to refer to the type of rates. And that's really all we want to refer to. We don't need to see particular rate values. We don't need formulation, things like that. So the level description is used by default now, but you can turn that off if you want. So that's like in the factorial table. Oops, I still have my report preview on. In the report options, if you want to go back to the way it was before, then you can use either the fields in the original protocol or in the trial. Either, if nothing has changed from the protocol to the trial, either of those options will give you the very same thing. But that will give you the old way per se of how things were displayed on the report. Any questions? Kind of fast and furious look at the different phases of a multi-factor. I was debating as we put together, this one was about, this session was on protocol. So I was like, how do we cover all the components? But you really have to. You don't want to just kind of leave things high and dry. So. Well, hearing no questions, we'll kind of transition then to the second half of our session today. Really covering best practices, I think is what I would call our look at applications. We won't really cover the basics of how applications work, but there's really kind of a common set of questions we typically receive in certain parts of the year. So we can always tell what parts of the world are starting the research season because we get questions about the spray seeding plan. I can't get my product totals to print. So you can pretty much point on a map just based on where those questions are coming from, what parts of the world are starting the research season. So really try to kind of compile all of those together to give a quick run through of those common points people get tripped up on, and kind of going to preface it with just an overview, a real quick overview of applications in general. And so the example file I have to walk through this, it is a trial, but I think everything we do is the exact same in a protocol. So it just typically, when I run this session, ends up being, I have a trial that has everything kind of rigged up the way I like to show it. But again, it's really pretty much the exact same if we were in a protocol, other than the site description versus protocol description is about the only main difference. So. So I guess to dive in here, just a real basic recap of applications in ARM. So in your protocol description or your site description, we can define applications, or really an event where one or more of the treatments are applied to the experimental unit, is essentially what an application is. And so we have, of course, a lot of documentation and description that goes along with that performance. And so all of those fields and information that needs to be put in for one of those events then is in a table here. And so we have, for each event, then we just continue to add more columns to this table for each of those events. And we use application codes. So we'll use letters to denote those different events. The reason for letters is it's nice to have a slightly different system than the treatment numbers that we refer to. We'll see in a moment how closely those are paired together. And so we don't want any ambiguity when you talk about application 1 versus treatment 1. So we use an application code and we refer to them as letters. So the first application event is application A, and then the second is B, and so on. And so we have all of this information to describe what is occurring in a trial. We've got all the documentation for weather details, soil details, when the application was performed. There's information about what stage of the crop or the pest is at when that application is made. equipment that was used to perform the application. So there's a lot of information, a lot of details that are all tied to that event. Of course, kind of the number one piece of information that matters is what product was applied. So we have a linkage. We want to be able to link a particular product to all of that information that we've described in our protocol description or site description. And so we do that here on the treatments editor. Let me real quick, auto size column width. It'll be a little easier to read. Here we go. So to the right of the rate information, when we're describing our treatments, there is a column for application code. And that is where we link the particular treatment components to the application event that is taking place. So we just put in the letter, and here you can see more than one letter. You just keep typing those letters in a row to link that particular product or treatment component with that application event. So a lot of times, it's pretty easy to kind of think of that application A as the first time I go out and apply products. And then the second time I go out to the field and make an application, that'll be application B. But depending on the research, depending on your treatment structure and the equipment that's used, that's not always the case. And so the example I have today will kind of highlight that. So I've got a made up product, Stomper Plus, and we want to apply it at 2 different rates, and actually kind of 3 different rates. But this 4th treatment here, we're saying is actually kind of the base stomp product with an adjuvant, and it has to be applied as a tank mix. So for whatever reason, we have a product that has some sort of difference in how it's being applied relative to the other ones. So as a result, if I go back to my application here, you'll see that A and B are actually applied at the same day. And they're almost the same. Of course, I've got the same weather details because they're applied at the same time. Really, the key ends up being in our application equipment. And this may be totally, it's totally fabricated. I don't know if it's a real life example or not, but I'm saying because of that tank mix, we're using slightly different equipment. We need to have a larger application amount, more spray volume when we're making that application. So as a result, we need to use a separate application code. So although the timing aspect of I'm going to go out once, I'm actually going to perform 2 application codes that one time. And then our example is 21 days later, we'll go out and make that same application again. So we repeat C and D are going to be basically the same example, but just 21 days later, we go out and make the same application. So going back to the treatments editor, we want to link that Stomper Plus product with that application A, and then also that application C, whereas our last product here is still the same days, but the application B and D. So it's somewhat of an odd example, but I think it's something that is occurring more often, at least in some industries. Certainly there's still plenty of research that's real cut and dried. It's one application, or it's maybe 3 applications, but it's all the exact same for every product. Just get it on there, get it on the plots and you're done. And in that case, a lot of this isn't as important. It's pretty straightforward to put it in. but definitely just depending on the research, you may end up with more complicated setup. And that's where I think ARM can really shine, just having the structure and the ability to be flexible to cover all these different combinations. Certainly makes it a little complex, a little tricky to get a handle on at times, but definitely has the benefits as well. So that's really our construct here for this trial, and really how applications are linked to treatments. So the next step, when we're ready to go ahead and make that application, well, how much of this product do I need to apply in order to make this application? And so we can go into the print reports in ARM and actually have ARM calculate that for us. So I made a report set here previously, just so I have all of the settings the way I want. But really, we're going to run the spray seeding plan. That's the report that will give us that information. We'll kind of dive into some of the options here as we go. I'm going to preview the report here on the screen so we can kind of talk about what we get on this report. So this report gives us our list of treatments, and we can control which columns of information are on the report or not, depending on what we want to see. But in addition to the treatment information, we get an amount of product to measure. So ARM is going to use the application amount and the mix size that we have defined in our application. And then based upon the rate that we want to apply that product, we can calculate how much we need to measure and mix up to make that application. And then we get to see the plot number specifically where that product is to be applied based on our map randomization. Some options here to control what is being done on the report. The first one is the product amount based on. So here we had chosen the mix size. I have a particular amount of volume that I'm going to mix up of liquid carrier, typically water as the air carrier, and then the product placed in it. And just based on if it's the certain jug size we always use, or it's the container that goes with my equipment, whatever it is, we have a mix size, that's our target. So that's what we'll calculate from. You can also change that basis to be the area of one plot, or maybe the area of one treatment. So basically that's multiplying by the number of replicates that we have in the study. So if I preview here, same report, except you'll see the product amount to measure now is how many milliliters of this product to mix up to cover those 5 plots instead. So just depending on what value you need to calculate to make that application, you can control that with the options here. We also have options for an application code. We can sort by the different application codes. And what this will do is give us separate tables for each application code. So here I have application code A, and I only get the treatment components that have been linked to application code A. Same calculations being done, but now we can have kind of a nice succinct list of what is going to occur at that application. And now it's going to kick out to a new page, have application B. In this case, we only had the one treatment, treatment number 4. Both components are involved. And then it'll repeat here, treatment, or page number 3. Now we're on to application code C, kind of same thing here. So this will split out by each application code, its own list of what products are linked and the amount to measure for that application. Maybe just show real quickly here. Some people might like each separate page, or each separate table, but maybe all on one page. If you go next and get to your print dialog, there is an option to remove the page break. So when there's a large enough space on a page, empty space on the page, we saw a moment ago, there was tons of empty space I had to scroll across. ARM can then remove that page break and put everything on one page, essentially. So if you turn that option on, now if I preview, you'll see we still have each table as separate, but it will put them all on one page for us. So if you want to save paper, just kind of have a nice compact report, that's one way to achieve that. Still have each different section, but we've gotten rid of all that extra space and squished it together onto one page. One more thing to point out here as we look at the kind of the components and where the information, where ARM is drawing some of the information for, making those calculations. This is probably one of the bigger things that I think trip people up is, for example, that the application amount and the mix size. Where does ARM go to determine that value? And it's kind of, it's a little bit tricky because there's a few different spots that you'll see that information can be entered. So in the protocol, it's on the application section, but in the trial, it's the application equipment. For each application code, we have that application amount and the mix size. That is the first place ARM will look when it goes to calculate the product amount to measure. All right, we're at application A. What is the mix size? It's going to look right here. The mix size is 2.64 liters. What's the application amount? Let's figure out how much product we need. And then when it's calculating a treatment that's linked to application B, it's going to come here. It's going to find the 250 and the 3.4 and use those values to calculate. Seems pretty simple. Unfortunately, you may have noticed when we were on the treatments editor, we don't have just application code. There's actually a spot for the application amount and the application unit. And in my hidden fields, there's also, let me just turn on all fields for a moment. And you'll see there's also a mix size and a mix unit. So some people just really like the compactness of having the treatment information and then the application information. And so it can be really enticing to start filling in this information over here. For some research, that's just fine. There's only one application amount. There's only one mix size for any application that's done. So it's simple, straightforward, and I like the way it looks. Okay, fine, that will work. But in other cases, it can actually be quite detrimental if, depending on which application it was, you have a different mix size or different application amount. Suddenly now you can't rely on just one value. That information might be different throughout the season depending on when that application is occurring. So now we can't have just one value. So that's why we have the application section. That's why we have all of this spelled out, even if it can seem a little bit redundant. You know, you look at how much information is the same across all these applications. This feels very redundant. It's to have that flexibility and that clarity to say, when this event happened, I can tell you specifically which treatment components were involved in this application, and I can tell you specifically what happened and what the calculations were. If you're working only from the treatments editor, the only way to get around that is to change these values. And then how do you know, looking back at this trial, what happened on A versus what happened in C when these values were changing? So it can lead to a lot of confusion. We tried to lock these columns at one point with that idea in mind of saying, okay, this is really going to cause confusion. It's not a good practice. You should put it in the application. It lasted all of a month because there were some trials where if your treatment itself is a different application amount or a different mix size, that's actually what you're testing. Well, now, okay, we can't lock this. You actually need that there because that is the treatment. So we had to put it back, but it was a great learning experience, I think, for us and a lot of people who were calling us as well. We got some testy emails and phone calls of it's not letting me put in my information, and we really tried to challenge some people as to why are you filling it in here. And just about we thought we had it after the first week of being able to answer the calls and be able to explain to people why they should put in the application equipment. We were feeling pretty good, but then we found an example where no, we actually have to have that. So regrettably, they're still there, but you really don't want to use them unless that truly is a part of your treatment that you're testing. So when ARM is performing calculations, it's going to look in your application equipment first. And if this is blank, then it would look at your treatment list. Say, okay, they didn't put anything in the application. Did they put something in the treatments? I can use that value then, I guess. Finally, if all else fails, if this is empty as well, there is yet one other spot. And so in your protocol settings or your trial settings on the application tab, we have that same application amount and the mix size. So this really should act as the default for when you go to fill in an application. That's really kind of what the purpose is here. It is kind of the fallback logic then if nothing else has been filled in. But it's best practice is to be explicit in your protocol description or your site description. But this is kind of that fallback. And it does remind me I did not show off the mix size calculator. I could do it here or I can show kind of the right place to do it. So I'm gonna go back to our application equipment. So in the mix size here, we actually have a little tool icon instead of a list icon. That's because it will pop up a little tool for us to use. So this is the mix size calculator. So kind of taking a step back just to look at setting up your application. We can tell ARM the application amount. That's essentially the rate that your carrier plus your product should be applied to your plot. So in my case, I've got 200 liters of water with my product mixed up. 200 liters across a hectare is really the rate that I want that applied at. So then ARM can take that information along with the number of replicates and the plot size in your trial and calculate the bare minimum amount of mix you would need to cover that area. So here I've got a 24 square meter plot. And at that rate of 200 liters per hectare, that means I need 2.4 liters of mix in order to cover that area. Typically, though, of course, you wouldn't mix up literally just 2.4 liters. You really need to operate with an overage in most cases. So you can specify to ARM how much overage to include. And whether you work with a particular percent, I just need 10% more, or maybe your equipment, you kind of know how much it takes to fill in the line. So I 250 mils will do it for me, and that'll fill my lines, or however much overage a specific volume you would use. You can specify that, and now ARM will add that amount to your minimum to give you a calculated mix size. So this would be 2.65 liters is what we need to be able to realistically cover the area across our 5 different plots for a particular treatment that we're going to apply. So that's where we were getting this mix size value. Certainly, if you have a case where you just have a specific mix size, we've got a 3-liter jug that we mix it up on, and that's just the way it is. You can always do the user defined as well. But having that calculated can be useful, so ARM knows how much overage you're working with if you have that flexibility for the mix size and what you're working with. Any questions? By a group so far. I do have a trial that I've kind of mocked up to be kind of a mess. So it kind of has all the big hitters of things that trip people up that I kind of want to walk through, and hopefully that will provide a good example for kind of things to look for. Like I said, it's kind of a certain stretch of the year. We get these similar questions that really trip people up. So we'll just open this trial up and kind of talk through each of them here. So print reports, let's generate our spray seeding plan. Load that report set again, just to put our options exactly the way we want. And so now if we preview the report, there's a few issues here. So the first one, as we look at our spray seeding plan, first one is that I have a separate table for each application code. But if I look at my report options, you'll notice I did not turn on that sort by. So I really would like a nice simple list of just my treatment list and my amount to measure. But for some reason, that's not what I am being given. I have these separate application codes, and I really don't want that. I'd like a nice, simple, small report. So there is a certain situation ARM will force the report to be split out by application code, whether or not you choose to do that. And the reason in this case of why that's happening is if we look at the details of applications A and B, it's pretty much the same as that last trial that we had open. So the application amount is 200 liters per hectare for application A, and it needs to be larger for application B. However, treatments 2 and 3 are being linked to both A and B. So depending on which application, application A, we can see that product number 2 has 82.5 mils to mix up. But in application B, that same treatment 2, we actually need to mix up 85 milliliters. So it's not possible for ARM to show one table with treatments 1, 2, 3, 4 in it and have only one product to measure for treatment number 2. Because it depends on which application is being applied, it's going to have a different amount. So it can trip people up if they don't realize that that one product, treatment number 2, has a different mix size. That's really why that amount is differing, is we have a larger mix size that second time we're applying it in application B. So ARM recognizes that and says, I can't give you the full story if I only print one table. So I'm going to split out by application code so you can see the right amount with the right application. So in our case, I can fix that, fix really in quotation marks because it's more of a hack than anything. Simply, if I unlink those two treatments from B, which of course in a real life situation would not be the fix, because if you needed to apply, you needed to apply it. But anyway, setting this back to kind of the way we had it before, now we have that consistency where treatment 2 has the same mix size, same application volume for every application that it's associated with. So there we can display it quite succinctly. It's always 200 liters per hectare across all of its applications that it's involved with. So it's always 82.5 mils. And so we have just the one table. So that's kind of the first problem. Usually that is kind of tied to what we talked about a moment prior as to the order of operations of where is ARM looking to find my mix size. A lot of times if people aren't using the application equipment tab, then there's some mismatch. It's blank on the treatment editor, so it was falling back to settings or vice versa, and just having kind of the inconsistent number depending on where ARM was looking at, then can trigger that table, and then we can kind of work backwards and find out that was what was actually going on. All right, next problem. If we look at this report, why is my treatment number 3 the first one in the list? This order doesn't make any sense. Why wouldn't treatment 1 be first and 3 in the middle? There is a report option to control that. So in your spray seeding plan options, I'm going to click on more options. And we have a sort tab at the top here. So you can sort your treatment list either by treatment number or by a replicate. So some people like to have that first, the order, if they're starting in plot 101 and they're going to go down the field, then they kind of like to have the list in the report be that same order. So that's why that is there. But you can change the sort by to treatment. And now when we preview the report, we'll have treatment 1, 2, 3, 4, 5 in that typical order. So that's a nice quick one to fix here. Moving on to the third problem. I've kind of carefully avoided it to this point, that treatment 3. Treatment 3 still is blank. There is no amount of product to measure. Of course, the check is blank, but that's because there is no product to apply. But treatment 3 has a rate, and it's got the application amount and mix size. So why is that blank? Why is ARM not calculating something for treatment number 3? The reason is we're missing a formulation type. So I would say probably of all of the issues we're tackling and showing today, that one is the most common answer. For the help me, I'm trying to get ready to make an application, I'm having some sort of issue. I would say probably 50% of the answers is formulation type. So this won't be the last time we're here. In this case, we accidentally left the formulation type empty for this product. And so without a formulation type, ARM doesn't know, is this a liquid formulation or is it a dry? Should we be weighing out the product in grams? Should I have a liquid amount that should be calculated? So it should be the very same as this other Samba Plus. It's an EC. Now let's go back. ARM will be able to know and perform its calculations now that it knows what type of formulation that is. And sure enough, now we have a calculation. The trick with the formulation type is you need to fill that in every time for every treatment. Even if you don't have a formulation concentration, maybe you're just given a product, it's a product off the shelf, doesn't matter what is the active ingredient, we don't need to track that. You still need to fill in the formulation type so ARM knows what it is. Is it a liquid? Is it a dry? And how it'll be applied. So that formulation type is very important, regardless of whether you have formulation concentration details. That actually is irrelevant in some cases. In some, depending on your rate, you may not need that at all to get a calculation. But ARM has to know what it's dealing with in order to calculate anything. All right, next issue on this report, treatment number 4. We do have a value here, but it's bolded. Why is this in bold? The rest of these are all milliliters per mix. So ARM has bolded this value because you'll notice it's actually 1.2 grams per one plot. So it did not calculate per mix size. It didn't use my mix size at all in this calculation. The reason is the formulation type. So for that product, it's a DL is the formulation type that's been entered. And specifically, it is an undiluted formulation type. So essentially, and really the reason it's so important for the formulation type is we're telling ARM 2 pieces of information in this one column. We're going to tell ARM, is it a liquid or a dry formulation that we're dealing with? And then when we go to apply that product, are we applying it in a carrier? Or are we going to dilute it at all? Or should it be applied undiluted? And so in this case, we've marked this super stomp as being undiluted. So there is no mix size. So ARM automatically is going to calculate the amount to product to measure based not on the mix size, because we're not mixing it with anything, it's going to go directly onto the plot. So it will calculate based on, in this case, our area of our plot, because that's what our rate unit is pointing us towards. And because the formulation state is dry, it calculated in grams. ARM won't bold if it's in grams versus milliliters, but it did bold on that report because of the different denominator, if you will, that it was calculating for one plot as opposed to calculating per the mix size. So maybe this was actually supposed to be an emulsifiable granule. It was still the dry formulation, but it actually is being diluted. If that's, I'll just change that formulation type to demonstrate then the difference now on the report. Now that this formulation is not undiluted, now for treatment 4, we have it being calculated per mix. It is still grams, so in this case it's grams per mix because it's a dry formulation, so we would weigh out that amount. But the basis is now for that mix size because it's being diluted first. So those are the 4 most common things we see. I have one more example I've rigged up for kind of talking through a granule application. It's kind of usually my backup plan. If I've run out of time, I won't even mention it, and we just say, all right, that was it for the day. And if we still have some time, then we can talk through it. So considering we still have a few minutes before our hour and a half that we kind of originally slated this for, we can run through this example if everyone's all right with that. So this is, again, kind of just from our support perspective. A few years ago, I had this question. I'd never heard it before. It took us a while to figure out how to make it work. And said, boy, that was weird. And now I probably have this question 3 or 4 times a season being asked. So whether it just is circumstance with the clientele that are using ARM now, or maybe industry-wide, it's more common. I'm not totally sure, but at any rate, figure it's kind of worth demonstrating in case you run into it. So the situation is that the product, we have a granule product. It was a dry fertilizer, for example, that is going to be applied to your plot, some sort of rate, a certain amount of weight per area onto the plot. But before those granules are put on the plot, we have a liquid fertilizer that we want to apply to the granule. So we've got this liquid that is going to be applied to the dry fertilizer, then those granules will be put on the field. So kind of a slightly unusual setup, and there's just a slight trick in order to get ARM to do all of the calculations that we would want to be able to make those applications. So what I have done here, again, anonymize the actual products in place, but we have the formulation type as the GR is our granule. So it's a dry formulation that's undiluted. We're not having any carrier. It's just going to go on straight, but we do have a liquid. It's also not being diluted. It's going to go right on that dry fertilizer. Actually, come to think, I just noticed that I was pointing at glue strip. That's not the right formulation. I think the L, there we are. That is a liquid, and it could be diluted actually. Talking through that, I realized I'm not even pointing at the right thing. So here, this liquid will be applied to that granule. And so the rate for that liquid fertilizer is, some amount of volume per weight, in this case, per ton of granules. And so I have attached those to two separate applications. So if I go over to the application equipment real quick, we just have, I left them pretty much empty, but just tacked on these applications just to be able to have them in use. So with that set up here, what you want to do is fill in that dry fertilizer information that we have. And now we will generate a spray seeding plan. And let's use the area of one treatment for the amount of, for our basis for what we should have the amounts calculated to. All right, this is about the third time this has popped up, so I should probably explain this, that I've changed the option so that product calculation is set to the area of one treatment, but kind of the second half of our spray seeding plan has a product amount totals, and that is still calculating based on the mix size. So it's just asking me, do you want to keep those two sections of your report? Should those have the same option? So that's why it keeps bugging me each time I change that, the product based on. So I've usually been saying yes. So that way those two kind of stay in sync. And just real quickly to point out that we had been dealing with this main table of product amount to measure. Underneath that, there is a product totals. And so that's what that prompt was asking us. Now here is going to compile the master amount of each individual product. So you can see, like, for example, our Stomper Plus, that was used both in treatments 2 and 3. So we're going to combine those and give a kind of a grand total of the total amount of this product we're going to need in order to make all of these applications for all of these different treatments. And so that option is just trying to make sure we keep things consistent as far as how things are being calculated, so that the amounts up above here logically match our grand totals at the bottom, is really why it keeps asking us that question. All right, so back to our granule application here. So our dry fertilizer, our granules here, we can calculate the amount of product to measure across. All right, I put in, let me check what option I selected. That's across all 5 replicates. I want to have the area of one plot. So this will give us the amount to measure across one plot. Sorry, I'm cross-checking to make sure I'm picking the right thing. I have area of one treatment. That should be 600. That's the reason I have a typo in my notes. My number wasn't matching up. So the amount of product the amount of granules essentially that we will prepare to cover one treatment. I apologize for the confusion. I'm going to change my notes here because it should be 600 grams, not 100 grams. So we get the amount of granules we will need in order to cover that one treatment, 600 grams. That value becomes our mix size for this application. So let's, essentially, we want to figure out how many granules are we going to need to apply to the plots. That's the amount we're going to want to douse in our liquid fertilizer. And that would be our actually in the time sequence, that's our first application that will happen, is dousing those granules. So we would go to the application equipment. And the application code that matches that liquid fertilizer was application F. And I want to have a user-defined mix size of 600 grams. So trick number is kind of really two little tricks, I'll say, to making this work. The first one was to get that amount to measure. So we have our 600 grams. And the second is that we'll actually choose the grams of seed as our unit. And the reason for that is you can see now this calculator changes. It takes away that whole area basis. We're not dealing with an area anymore. And so now this will give us the right calculations. We're not applying our liquid to any particular area. We're instead applying it to an amount, a number of granules. Or in this case, a weight. We're weighing out 600 grams of those granules, and that's what we're applying it to. So as a result, we really don't have an application volume being undiluted, or if you did need, if you were diluting that liquid fertilizer first, you could set that there. But if you weren't, you can certainly have 0 as the slurry rate. It kind of hand shows us one of the units that kind of pairs with the mix size. But the key is let's get the mix size to be that amount of granules that we'll be using. So I put that in application F because the liquid fertilizer is linked to application code F. So as a result now, we'll be able to calculate that we need 2 liters per ton of our dry fertilizer. Now we have a specific amount, that 600 grams is how much we'll actually be using. So now we can calculate how much liquid we will need. So if we go to our report preview, I haven't messed anything else up. Now we have 1.2 milliliters per mix. And that mix again is that amount of dry fertilizer we'll end up using. So we'll need that 1.2 milliliters of our liquid fertilizer will be put on those 600 grams, which will then go out onto the field. Hopefully that made sense, or you won't face that problem and won't have that particular setup. Certainly if I butchered it, you can see in my corner, it's getting late. So I think that would explain the butchering of the steps. But to recap, calculate the amount of dry product you need. That's how much, that's your mix size essentially for that liquid application before it goes out to the field. And then that gives ARM the information it needs to know to give you the amount of liquid.
Hey, Matt.
Yes.
for this treatment 5, looks like it's very similar to the way we calculate the amount of, for example, insecticide for seed treatment, correct? If I have a seed treatment trial, I need to spray certain insecticide over the seeds and then plant. It's the same type of a procedure, correct?
Right. You're exactly right. Yeah, so you have really kind of a pre-application, if you will, that has to happen before the field is even involved. And then you have the actual seeds going in. So you're exactly right. And the trick is then getting that amount so that ARM knows, well, what am I dealing with? How many seeds are you talking about when you want to put that product on those seeds, or in this case, the granules? So you're exactly right. And really that kicker is just, let's give ARM that information by way of the mix size, and tell it that's how many or how much we're going to need prepared for those plots. And then it can give us that calculation.
Perfect, thanks.
Yeah. Any other questions? While we were in this application equipment section, I had just one last note when we were looking at, right now it's labeled the slurry rate because we were in the grams seed, but if you are in a different mix size here, your application amount, there's a lot of different units here, which is, you know, great for flexibility in all different types of applications and research. There is one that I almost think should come colored in red or hidden or something. It's this kilograms per hectare. It seems very innocent. It doesn't really stand out relative to any of these other ones. And in fact, I bring it up because it definitely looks pretty good in this type of application where you're dealing with a weight, kilograms. That's what I want. I want something in kilograms based on the area on my plot. But the kilograms, if I look at the full list here of the application amount, the kilograms per hectare is actually kind of a special unit. Really it came from a request for Asian rice trials. Just the certain way that they're setting up their applications entirely is going through a different sequence essentially of calculations. So although it looks just like any of these other units, it's actually quite a bit different in how things are calculated internally in ARM. So in most cases, if you choose a kilograms per hectare for your application amount unit, you probably won't get a calculation on your spray seeding plan. Again, unless you're in that particular type of study where you're setting up your application that way. So it's just kind of a word of caution. It looks pretty normal. I think there might even be some prompting when you choose it I don't know if it'll do it here or if it'll be, if you're in the treatment editor or where, but we've tried to put in just some warnings along the way that this is just a little different than what it might appear. Most of these, as you look for a pattern, a lot of these are, you know, dealing with a volume per area, volume per area. A lot of these kind of have that same structure to it and that weight per area. It looks good. It really looks like, hey, that's what I'm looking for. But it actually, in most cases, isn't. So I just wanted to bring that up. That's kind of another tripping point, especially for these type of seed treatment or fertilizer studies. I think people gravitate towards that unit just because it looks like the types of things they're trying to convert between, but it's little bit of a red herring. Most of the conversions are done kind of in that rate unit section instead anyway. All right, well, that was the end of my list. I appreciate everyone joining. If you do have a question, feel free to send us an email. Hopefully we'll be seeing you at a future webinar, at least for this month here, month of April. We're trying to expand our typical time frames to meet this region, because we know that the sessions we usually have are nowhere near a good time for for this region to participate in. So hopefully we'll be able to have even more people join us. Spread the word if you have colleagues that would want to participate as well. Let me bring up that list here just to highlight those other sessions. We're kind of trying to work through the whole season. So we did protocols. We're excited to show off our new mobile app. So kind of talking about data collection options. So we'll show off the mobile app and talk about what it can do and give a short demo next week. The following week after that, really not so much about the mobile app, but an excuse to talk about a couple of features in ARM that are great to use, whether or not you use ARM mobile. SEs and your lists, favorite lists. And then we'll talk about the data, putting the data in, reviewing the data and analysis, and then kind of a general Q&A at the end. So that's the rundown. I appreciate you all sticking with us. An hour and a half is kind of long, but we had everyone stick with it, and hopefully we'll get to see you again next week. So thanks, everybody.
Thank you. Bye-bye.